With the development of wireless networks and the spread of broadband access, the number of active mobile user devices continues to grow, with the smartphone being the most popular among them. They include low-end, mid-range, and of course high-end devices. They do vary in build quality, utilized type of material, screen size, screen technology, but the biggest differentiator relates with the CPU, GPU, RAM, as well as integrated wireless connectivity modules. Another issue is the type of installed OS. Nowadays, two operating systems share approximately 90% of the mobile market. That is iOS from Apple and Android from Google. The first one is a closed environment dedicated only to devices coming from one manufacturer. The fragmentation and distribution is very low. The second one is an open environment available on numerous devices coming from various manufacturers. Additionally, this OS may be changed or modified. The fragmentation and distribution is very large. The question remains which option proves better in terms of quality for the end user. One may assume that if a given solution is intended as a dedicated one, it should prove to be more effective. The battery lifetime, stability, and efficiency is expected to be high. If some solution is universal, it would eventually prove to be less effective, less stable, and with a lower expected battery lifetime. This aspect would surely be an interesting hypothesis to investigate. Currently, many providers are investigating in deploying 5G network infrastructure. However, still, a vast majority of mobile devices is compatible with 3G and 4G technology. Not to mention network coverage issues where LTE is the leading solution for urban environments. This paper aims to investigate the mobile user experience related with iOS and Android-powered smartphones. As we know, the term quality can be understood in many different ways. One focuses on the technical side, described as quality of network and quality of service. Others focus on the user side, described as quality of experience. In this work, we present an evaluation carried out under real-time operating conditions at a university campus, considering the performance of the LTE network. The study involved 14 mobile devices, including 7 iOS and 7 Android smartphones. The research scenario was based on the crowdsourcing approach in which the utilized devices consisted of personal students' equipment. The measurements were carried out using a custom-built application. For each OS and every device, the measurement campaign was carried out in an indoor environment. Each person performed his or her measurements at 10 unique points with more than 30 measurements per point. Obtained results have shown an observable difference between the closed and restricted iOS and the open and fragmented Android system. In case of download speeds, the results for iOS were close one to another with generally higher throughput compared to Android, which had a greater spread. For iOS, the mean value ranged from approximately 90 to 100 megabits per second, with a median value oscillating from 20 to 89 megabits per second. Whereas for Android, it varied between approximately 24 to 102 megabits per second and approximately 21 to 107 megabits per second, respectively. When it comes to upload speeds, results were quite similar comparing one group of devices to the other. For iOS, it ranged from 9 to 26 megabits per second in case of mean, and 9 to 22 megabits per second in terms of median, whereas in case of Android, it was equal to approximately 10 to 23 megabits per second for the mean, and 9 to 20 megabits per second for the median. Peak values were also most often lower for iOS, with both mean and median values oscillating from approximately 16 to 33 milliseconds. Whereas in case of Android devices, the mean value fluctuated from approximately 16 to 36 milliseconds, and the median varied from 16 to 37 milliseconds. According to our findings, iOS-powered devices have a noticeable advantage when it comes to utilizing offered network resources. Probably this is related with a higher optimization of the hardware-software aspect linked with lesser fragmentation in terms of built-in components and version of the operating system itself.